So yeah, it's cool fun. I'm working on open source, and so the things that we'll go over on this one are all free. Although some people choose to pay for things, and I'll also mention those things too. How many folks have heard of distributed tracing before? Okay, and Zipkin maybe? Okay. So I won't do a big thing on distributed tracing itself, but a wee overview. It's not too much time for that, but there's plenty of materials out there. And at the end, I'll put a place to go to chat with humans and find out about the other materials out there. But so I've already been introduced, so we'll just skip that. Distributed tracing, haven't been working on terribly long. It's been about 4 or 5 years, something like that. And I started at Twitter, where this project called Zipkin was born, although it's currently a volunteer-maintained thing called OpenZipkin. Anyway, distributed tracing is mainly about tracking those requests that go through your system. And so the distributed part, meaning hitting different nodes and services like your cache and your database, and being able to follow that request as it goes across. And similar to like request IDs or correlation IDs that you might have in log files, it's going to have a unique ID there. And then different than that, it's actually going to have an ID for each individual step, which can allow you to get true causal information as opposed to like timestamp circumstance. And these can be especially helpful when we have more event-driven architectures and more async things going on, where it's harder to track just by looking at timestamps and things. And because these causal IDs are there, it allows system to build things that are otherwise kind of hard to parse out, like mainly diagrams, at least of the request as it goes through, and maybe even some aggregations like what the service itself, where the service connections are going to. And the why do I care side is part of this. Like the set your sites thing, besides just being a horrible pun, is that we're a volunteer group. It's mostly end users who are actually setting this stuff up and using it on their own. And why do they care is actually what this slide is. Why do I care? Because I like helping them. And the first thing people think of with distributed tracing is really kind of reducing that time in triage in the blame game, and trying to figure out where's the best place to put the blame. Like, how do you focus the blame effectively instead of it's always the database? And I mean, it usually is. The other thing is that just providing a visualization, because people think about things a lot differently when they're presented a picture as opposed to presented a table form. And I'll show you an image like that. And this helps because we're increasingly a service mindset. And so if you have a service agreement, like SLA, SLO, these things, then you're more aware of what things that you're making your counterparties endure, and what your counterparties are making you endure. And so you're looking up and down often to see like where your impacts are coming from and who you're impacting. And I kind of hinted at it, but the complex architectures, like I haven't really heard a lot of people saying that year on year our architectures are getting simpler. Like, in reality, they're getting a little bit more complex from both a programming standpoint and also from a topology standpoint and provisioning. We're getting better tools. It's getting much easier to deploy complex things, but they're still complex. And so we need some more tools to understand those, and this is one of those tools, not the only one. There's plenty of folks who are trying to increase this monitoring / observability landscape here. And so an example long trace, this one is actually, Zipkin is the name of the system, but also we use the tool ourselves to kind of diagnose our own performance problems. So this is actually an example of a trace diagram, and the top line is the first service that request hit, and then each of these little steps show either different components or different services, and so for example, if you were able to read this, it would be a long post request at the top. followed by a little bit of time in service, deciding what to do, and then a whole bunch of like forked activity, looking for Elasticsearch templates, and eventually storing some things. And so that top line, if it's service originated, like if the trace starts at the service, then that's the part you can affect that can directly help reduce that that response time from your counterparties, whether that's a client app or whether that's another service. Traces don't have to start at a server. They can actually start in Angular or in a iOS or any other thing, or even like an IoT, like a dishwasher. But at any rate, just to simplify things, we'll start with a service. And so, like for example, in our case, we noticed that the actual caller didn't need to hang around for all these other things. They were happening asynchronous anyway, so there's no point in just blocking them for no reason, because there's no good that they could have done by waiting an extra period of time. Before, it was happening after they left anyway, so we could just reduce that latency. So like, unnecessary time blocking can also be called as latency, and fix that thing. And what happens is when people see diagrams like this, they're able to pluck off low-hanging fruit. Like somebody could actually have an intelligent conversation, even if they don't understand the code, by looking at these sort of things and say, well, what if those things happen in parallel? Could they happen in parallel? And it lowers the barrier to entry. So people who aren't necessarily, often it is people doing code, but it's not limited to that. Also, you can draw these service diagrams. And this one literally is the diagram of a dishwasher. So, we live in an IoT world. It may not just be users complaining, it could be other counterparties, it could be your angry dishwasher. But at the point that we live in a service architecture, sometimes we have services that are intentionally hit and some things are not intentionally hit. And so it's useful sometimes to see an aggregation of services involved in a request, maybe something still hitting a deprecated service that it should not have been hitting. You made the code change and it's like, yep, let's have the party. But nobody checked to see if it was actually still being called. And oh, well, it didn't deploy. And so you could actually, by another thing about seeing things is that this is interesting. So like these type of tools exist in a lot of like APM, like performance management tools out there. But Zipkin is a relatively cheap product that you can run. And it's one of other options that can draw these things for you. When I say cheap, I don't mean cheap like open source, because open source is just the cost of the license of the software at the end of the day. What I mean is cheap is like how much does it actually cost you? Like how many people, how much like Elasticsearch nodes and things like that. And when we went to talk to all of our sites, we couldn't find one that spent more than single digit, and most of them had less than a % of their IT spend in tracing. Now, how do you turn it on? This is the question a lot of people come, like, okay, I want this, let me turn it on. Now this is where like your usual performance management company will have a better answer, because usually they're like, okay, we'll just put these agents everywhere and magic. Like, and that costs you money, but it could be a good choice for you depending on your circumstances. But usually there's some pieces involved. Tracer would be like a library inside of the apps that are collecting things. It might even be a library inside of an agent. It doesn't require to be sitting in some place, but something is schlepping data at the Zipkin. And we have this word called instrumentation, which is the thing that's actually trying to make intelligent choices of where to time things. So if it's a web server, then it's going to be choosing like when the headers are sent, it's going to stop the timer there, or like making some intelligent choices. And something's configuring it, whether it's agents or whether it's people using Spring Boot's autoconfig or what have you. And the server itself can be as simple as a single file, like it's written in Java. That's good depending on what you think of, but you can also pretend it isn't. It has a Docker container. The main idea is that some folks just like throw one of these on, and if you have certain types of things in your architecture, then they will automatically be sending out trace data if you point it to one. So. Now let's get into the Zipkin site itself, because I've got a lot of content and I really want to focus on end users here. So when we call a Zipkin site, we're really talking about production deployments, because it's sort of like if I make something, like I make like a demo for a conference, I don't really consider that a site. Like, it's interesting, but it's not necessarily going to teach me any lessons about how the software works in practice. So I'm really talking about actual things that people are using to help themselves. And site owner, because it's an open source community, we're talking about like somebody who's actually at the bank or at the enterprise or at vendors sometimes who are champions there. Almost always they're part-time. This is just part of their job. Like maybe they're also in charge of the logging system. Maybe they're actually part of normal enterprise software development, and they just happen to be interested in this because it makes their life easier. So that's sort of like lingo I'm going to use here about site and the owners of the sites. And so we have this like wiki page where we've asked people to give us information willingly. So Zipkin as a community, we decided against the whole like logo boarding thing. We think that's disingenuous because it's just like, do I have a logo because they're in production? Do I have a logo if they say they're in production? Are they really in production, or just do I have a friend there? Like, and so we instead have a smaller list, but it actually tells you exactly what their setup is. Are they using Elasticsearch? Are they using Amazon? What type of applications are there? How many people are working on this type of thing? How many developers are supported? So that's the sort of stuff we have, and I'll have a link at the end so you can just like browse through there if you're interested. Because what we found was that the thing that was most important for building confidence in one's ability to roll out stuff is knowing they're not alone, and that there's something else, sort of like what I'm doing. And so logos help a little bit. That gives you confidence, but if you really want to like relate to it, you need to sort of see more than that. And so we took the challenge on. So we asked some of them, why bother? Like, okay, is this just type thing? And somebody said, okay, tracing, it needs to be in the box. Or did you have some things you actually achieved with this? And there's two sides of the question. One is like the conjecture, like this is what I think it should be, and then there's the reality. What does it do? And so Ascend, which is in Thailand, a financial services company, the things that they were using was basically to like validate. So sort of like, okay, well, we have this cloud transformation project. How is it working out for us? Like, so it was a monolith before, and now we split this out. Does it still work? Are these calls, is the latency actually reduced? Is it important if it's reduced or not? Like, so you can have another frame of reference for those things. And particularly as architectures are having transformations, you may be out of conformance without knowing it. So for example, if you're supposed to be routing all of your requests through like this API gateway or something like that, but you notice that they're actually not going through it. They're just following the side door. Somebody's got a DNS address and they're hitting it. And so like you can actually identify these non-conformant service behaviors. Hotels.com, we're looking more along the lines of just that sort of like tuning. And what are the low-hanging fruit to optimize requests? Because if you're doing something like a booking website, you can imagine that we've all used those things. And as they've taken like chugging along, like you want those chugging to take less time. So there's some environments where the end user response time is pretty important. And Netflix, they're a site of ours too. And the thing is that in that case, they're more about making the developers productive, because maybe they don't hire a huge amount of staff. They want to make each of those individuals more productive at solving problems. So there's a lot of emphasis on developer productivity, and then also the operations visibility. Operations visibility would eventually lead to questions being answered such as, does 5 retries ever work? Like, yes, I have 10, or is it, I don't know, but like we use numbers like 5 and 10. Are these actually smart numbers? Do they ever work? Like, when you start getting these causal diagrams, you could, especially if you have analytics at the end of the day, you could start answering some interesting SRE questions. Infrastructure involved, there's the things that are actually your apps, and they have something that's sending data about the commands happening inside of them. And not your whole architecture is usually not actually in sight. And that means that you have a combination of things that are instrumented, like things you can control, and things you can't control. They might be like, maybe you're not going to be able to get MySQL to tell you about its query plans, but you could say how long you're waiting for MySQL, and that's important. And so that's the the production side of the app, of the tracing architecture. You've got the transport, which is like how the data gets there. Sometimes people use just HTTP, sometimes people use Kafka, things like that. And the bottom line is that different sites are going to have different architectures. There is no one architecture. You can't just say like, thou shalt be Kubernetes. Like, there's usually a combination of things out there, and people do not want to limit themselves to only seeing the new things. So that's why having an open architecture is important. And that means that, like in reality of a site, it means that we have folks who are in the infrastructure, contributing code, contributing information to others that are not running, sometimes not even running Zipkin server at all, because, for example, they're using a SaaS or they have another in-house implementation that uses the same data format. Like, it can get messy, right? And that's the real world. So it's important to know that there are different options. Like, so for example, one startup in Tokyo is using a Google Stack driver because at the level of requests that they're making, the SaaS was a better price point for them. And hotels.com, they're a part of the Expedia group. And so Expedia has like a new telemetry project out there. It's also open source called Haystack. So while all their apps are sending out Zipkin format, Haystack can eat that format. So they just, they let it eat it. And you have hybrid setups, like Yelp are an interesting site because they simultaneously want to have like 100% of data, but they can't like keep that much data forever. So they have like an hour with like a fire hose, which is available for customer support, but they retain like a sampled like a 1 out of 1,000 requests for longer periods of time. So site setups are different, and you may find yourself in one of these positions. The applications themselves, we don't have like an exclusive agreement that you must use this brand of library. That's really going to work against you if you try to do things like that, because at the end of the day, if you're a system, you want the data. Like, you hope it's in good shape. That's the one thing you hope, is that the data quality is there. So we mainly focus a lot of energy on curating data formats and propagation formats like header formats and things, so that different parties can both send and receive these things, and that opens up the ecosystem more. This is a 30-minute minus some deck, so I can't get too much into details, but I promise you, if you want to grab me, I can answer questions, and there's some more notes here too. So we have, like I mentioned, hotels.com. Like, it's an example of a site that used to be like like pure Zipkin site, but then as their architecture changed, they moved around. And in this case, they were moving towards this Haystack. So what they had was like a sort of like a data proxy called Pitchfork, which would take the data that the apps are sending along and then slap it into a Kafka topic, because the Haystack is basically a K-streams. It's like a streaming architecture there. It's pretty neat. But their developers are not necessarily going to want to start like a Kafka architecture on their laptop. I mean, we have our fans turning on just by using Chrome, right? So we don't always want to run like the entire world. So when the developers are working on their own apps, they may be starting a microservices architecture in a Docker Compose or something like that. But in that case, they might just be using the Zipkin server so that they don't have to change the way the app is wired. They just point it to a local thing that doesn't take much memory or anything. And so it's a combination of using the powerful stuff and production in a very easy dev setup. Netflix, at this time that Zipkin was created by Twitter, it was just one of many companies making the same sort of thing. They just happened to open source it first. So a lot of the large consumer brands will have like something that's very similar to Zipkin, or something that's like an alternative to it. And so they had their own one that was called like Salp or something like that. And so they retrofitted the libraries that used to report to that system to switch it. And one of the reasons why they did was that they were increasingly using Spring Boot apps in their newer architectures, and those were already coming in with Zipkin support. And so it was easier for them to just take like the same data pipeline and start moving things forward into that. And more recently, as of like this week, they're working on another system called Edgar, which is another tracing system that they're going to re-schlep the data into Zipkin for. And the reason why people do that is that they want these service diagrams to have more of their site there. So like if you have multiple systems, if you can get things into the same box, if you will, then your analytics are better. The support story is better. So for example, if someone's troubleshooting a specific customer request and they're using Edgar to do it, now there's additional details might be available in the same trace when you're talking with the data services team. And like I mentioned before about the SaaS, you don't have to actually use things. And of course, if you're working at Amazon, now they have this X-ray thing, which it means that if you start requests at like Amazon API Gateway or something like that, it can actually already start traces on your behalf if you're using Lambda. They actually do tracing around Lambdas, and so you can actually collaborate with those traces. And then we do. I was like kind of pointing out the edge cases, but we do have sites that are like, hey, just give me the binaries and I'm going to run them. And so Metadata is an example of that. They're using an Amazon-based deployment, but they're using a stock Zipkin server against like managed Elasticsearch. And it is stock, but they wrote a different tool. Like a lot of people are SLA focused. They took the same data and made these things called SLAP reports. So I don't really know how they came up with that, but it was a backronym, I'm sure of it. But anyway, if different folks are violating SLAs, then they would be able to see exactly what services upstream were impacted, and that could help drive behavior. So things that are different across the sites are things like data retention policies, how long you collect data and how long you keep it around for, how much is useful, how much can you afford. These stats, you can get the slides later, but more important thing is that like adoption rate is something people don't always talk about. We talk about like, here's the thing, and yet everything's still in Splunk. Like it's interesting to know where folks are at, and one of the neat things about tracing is that because it's drawing a diagram for you, you can actually see the adoption of your own system. So you can actually see progress, as it relates. And so when someone asks you how many services are doing this, it's one of the few things that can measure itself because you can actually, answer that question. But how do we get started? Like I got 30 seconds left. So not everybody's in a greenfield situation. If you're in a greenfield situation, actually, you make your own choices on just about anything. But Hotels.com were mentioning that single service or even monoliths are not a bad place to start because you can still get insight into what's upstream and downstream of you. And even in those compartmentalized space, you can build experience and you can understand if it's working for you in a smaller surface area. These tips are going to work with anything that says they're tracing, basically. Proxies are another interesting thing. That's why you find like SDOS tracing integration via the Envoy product, because proxies by nature are schlepping data here and there. They're also a pretty decent part to get started. And then also you can just follow the frameworks that have things built in, and then like have these position views, and then as things go, you can choose which of these or combination of these can help for you. Anyway, I have the link, but you can't see it. But I'll post the slides and Twitter tag them. But we do have site documents. We do encourage people to share them, but also understand that it usually takes like a month of asking legal people to actually share this type of information. So appreciate if you take those punches for others. But we do have an open chat group. Gitter is sort of like Slack. It's like GitHub. And it's run, I think, by GitLab at the end of the day. Most of our online communications happen there if you have questions or want to chat with folks. And then, our main repository, if you like things, you can click stars on there. People like seeing those things. Anyway, thank you for enduring my talk. And if I don't think I have time for questions, do not? Okay.
Hey, Adrian.
Hi.
Hi.
Hey, Everett. So, Everett had asked about how does Zipkin fit into open tracing? So, Zipkin is a system, and there's this thing that's marketed open tracing, which is a library interface. So, if you think about, I'm writing like Java code, then I might have a library for like logging or something like that. And so, the way that the libraries are defined then that might be important to you. So if you have something that's open tracing branded, then, for example, Zipkin has Go and Java libraries that that plug into that API interface. But at the end of the day, open tracing is a library API definition. So it's not a data model or data format. So that's sort of where the relationship goes. The open tracing project has sort of decided to merge with another project. And now there's this thing called open telemetry, which is supposed to be carrying that stuff forward. So hopefully that will be the place where people can follow these things moving forward. I know that they froze the Java version of the API at 0.33, and now we're carrying on the brand in another brand called Open Telemetry. Other questions? All right, thanks. Can't wait to hear the next talk.